Okay, number 6 says let f of x equal x cubed minus 5x squared plus 7x. It says use the second derivative test to determine which critical numbers, if any, give relative extrema. So kind of reminder, you're going to find the critical numbers by setting the first derivative equal to 0 and solving. Then substitute these critical numbers in the second derivative to see if they are concave up, which means that it's positive, or concave down, which is negative. And then remember, if it is concave up, then there is a relative maximum at that critical number. If it is concave down, then there's a relative minimum at that critical number. And then if it is concave down, then there's a relative maximum at that critical number. So the first thing we got to do, we've got to go ahead and find our critical numbers. So to find the critical numbers, remember we're going to take this first derivative and set it equal to 0. So here's my equation. Take the derivative of x cubed, I'm going to get 3x squared. Take the derivative of negative 5x squared, I get negative 10x. And take the derivative of 7x and get plus 7. Set that equal to 0 and factor it. So I got 0 equals 3x squared minus 10x plus 7. So I got 3 and 1 for my first ones, negative 7, negative 1 for my last ones. And so that's going to factor down to 3x minus 7 times x minus 1. I set 3x minus 7 equal to 0, and I solve to get x equals 7/3. I set x minus 1 equals 0, and solve to get x equals 1. So those are my two critical numbers. So now that I have my two critical numbers, I'm going to go ahead and find my second derivative. So to find my second derivative, well, here's my first derivative. I'm going to take 3x squared, take its derivative. The derivative of 3x squared is going to be 6x. And the derivative of negative 10x is going to be negative 10. So now I'm going to go ahead and substitute in my two critical numbers in the second derivative and see whether it's positive or negative. So I take 7/3. I substitute into my second derivative. So I got 6 times 7/3, which is going to be equal to 14, and 14 minus 10 is going to be equal to 4. And so that is positive, so that means it's concave up. So if it's concave up, that means that I've got a relative minimum at x equals 7/3, and then when you substitute that back to the original equation, you're going to get 49/27. So take 7/3 and substitute back into the original equation. So notice here's my original equation right here. My original equation, which is x cubed minus 5x squared plus 7x. If I want to find that y value of it, I just substitute that back in. So remember, so I'll show you got x cubed minus, and then it says we have 5x squared, and then it says that we have plus 7x. I'll have to take a calculator and substitute that in. Take a calculator. Go to alpha f1, create your fraction. So your fraction says we're going to substitute in 7/3. So if I take 7, put the 3 down here, go off to the side, take that to the third power, and then minus, and then it says I got 5, hit alpha f1, hit your fraction, go ahead and type in, sorry about that. Let's go ahead and try to type that in again. So I got, we'll put parentheses around it just to make sure that it's coming out okay. So I got 7, I got 3, and then over here, put that in here, take that to the third power, arrow off the side, then I got minus 5, and then go ahead and put parentheses, and then hit alpha F1, hit your fraction key, and type in 7/3. Oops. Then arrow off to the side, put in the other fraction, take that to the second power, and then put in plus 7, and then put in parentheses again alpha F1, hit your fraction key, and then type in 7, type in thirds, and make sure that you're outside of the parenthesis when you put the end parenthesis there. And then just hit enter, and you got 49/27. So that's how you put in your calc and find those exact values if you want to. So notice again then on this problem right here. So I'm going to go ahead and take my critical number right here, which is 1. Put in the second derivative. So I got f prime 1, so that's 6 times 1 minus 10. That's going to be negative 4, so that's negative, so it's concave down. So that means that at that point of x equals 1, I've got a relative maximum. And again, you can just type that into your calculator to find out the value that goes with it. So remember my original equation again, substituting that 1. So my original equation is this right here. To find its exact location, you can just type in 1, put your power key, hit to the third, then minus 5, and then hit times 1 squared, and then plus 7 times 1. And get that answer of 3. So those are your relative maximums and relative minimums. Okay, now this next one, got the limit as x approaches infinity of 3 minus 2x, or 3x minus 1. So on this problem, we use our calculus rules to find this limit. The calculus rule says divide all the terms by the x variable in the denominator that has the largest power. They use the fact that the limit as x approaches infinity of c over x to the n is 0, and also the fact that the limit as x approaches infinity of c equals c. So notice, here's my highest power right here, so I'm going to divide every single term by it. So I take this 3, divide by x. I'm going to take this negative 2x and divide by x. And I'm going to take this 3x, divide by x. And then I'm going to take this negative 1, divide by x. Simplify that down. So notice this stays the same. This x's cross out, so you're just left with minus 2. These x's cross out, you're left with 3. And then you got minus 1 over x. And that stays the same. Now using those rules right here. So this first rule says I've got c all over x to the n, that is equal to 0. So since this is c all over x to the n, so that's going to be equal to 0. I'm going to take each one of these limits separately. So notice this one right here goes to 0. This one right here, constant, so minus 2. This one right here stays at 3. And this one is going to go to 0. So working that out, I got 0 minus 2 is going to be negative 2. 3 minus 0 is going to be 3. So your answer is going to be negative 2/3. Okay, on number 8, it says that it wants to go ahead and use the techniques learned in this chapter to sketch the graph function y equals 3x over x squared minus 1. So there's my equation right here. I got 3x over x squared minus 1. So remember the very first set of rule, you're going to find the domain and the range and any asymptotes. Then you're going to use the first derivative test, and then you're going to draw the graphs. Okay, so we're going to look at the domain and the range, any asymptotes. So basically that's what we're doing is we're finding the vertical asymptotes. So remember your vertical asymptotes, take the denominator, set equal to 0 and solve it. I factor x squared minus 1 equals 0, I get x plus 1 times x minus 1. So my two vertical asymptotes are going to be a negative 1 and 1. My horizontal asymptotes, I go ahead and compare the numerator power with the denominator power. So this power is 1, this power down here is 2. So remember the numerator power is less than the denominator power, so that means that my horizontal asymptote is at y equals 0. Okay, now that I've done that, I'm going to go ahead and find those critical numbers during the first derivative test. I'm going to go ahead and take this equation right here, and I'm going to use my quotient rule to find my first derivative. So to find the first derivative, take the derivative of the numerator. Derivative of the numerator is 3. You can leave the denominator the same, which is x squared minus 1. You got your minus sign. Now I'm going to take the derivative of the denominator. The denominator of x squared is going to be 2x. And then leave the numerator the same, which is 3x. And then that's going to be all over the denominator squared. So taking the denominator and squaring it, I got x squared minus 1 squared. So here's my first derivative. I'm going to simplify it down a little bit. And then I'm going to go ahead and set the numerator equal to 0, the denominator equal to 0 to find my critical numbers. So first off, you're going to notice that I distribute this 3 on 3. I'm going to get 3x squared. Distribute that on 3, I'm going to get minus 3. Negative 2x times 3x, so that's going to be negative 6x squared. So then I combine my like terms. Well, my like terms are right here. I got 3x squared minus 6x squared. That's going to be negative 3x squared. That's still all the denominator squared, so that's x squared minus 1 squared. So here's my first derivative. And my first derivative, find those critical numbers. I'm going to go ahead and take the numerator, set equal to 0. So here's my numerator, set equal to 0 and solve it. I divide by negative 3, I get 0, take the square root, and I get 0. So that just gives me that critical number of 0. So I take x squared minus 1 squared, set equal to 0. I take the square root of that, I get 0. I add 1, I get 1. I take the square root, and I'm going to get x equals 1, and negative 1. So there's my intervals I'm going to be setting up. So with those intervals right there, you're going to notice that setting up my intervals right here, I'll just make it a little bit smaller so you can see that here's my critical numbers right here. And then I'm going to take those critical numbers and set them up into intervals. So here's my critical numbers of 0, 1, and negative 1. So I'm going to go from negative infinity to negative 1. Then I'm going to go from negative 1 to 0. I'm going to go from 0 to 1. And then I'm going to go from 1 to infinity. So there's the intervals that I'm working with. So I'm going to take those intervals right here, and I'm going to choose those test numbers. So choosing my test numbers in those intervals. So I notice that negative 2 is between negative infinity and negative 1. Negative 1/2 is between negative 1 and 0. 1/2 is between 0 and 1. And 2 is going to be between 1 and infinity. Now take these numbers right here. Remember to substitute them into the first derivative. So here's my first derivative right here. And notice that my first derivative, no matter what, this denominator is always going to be positive. So it's basically just finding out what the numerator is going to be. And let me scroll this up and use this second one right here. So notice this is always going to be positive down here. So I'm just looking at this one right here. So I take that negative 2, and I square it, that's positive, but a positive times negative is a negative. So that's going to be a negative divided by a positive, so that comes out to be negative, so that interval is decreasing. When I take negative 1/2, negative 1/2 squared is going to be positive. The positive times negative is a negative, and negative divided by positive is going to be negative, so that's going to be decreasing. When I put in 1/2, you're going to notice that that is going to be negative, and negative divided by positive is a negative. And f prime of 2, same thing. 2 squared is positive, 2 times negative 3 is negative, divided by positive is a negative. So every single one of those intervals are decreasing. So this is what your graph is going to look like when you actually set it up. So notice first off, I'm going to go ahead and put in my vertical asymptotes. So my vertical asymptotes I found out was at right here, negative 1 and 1. My horizontal asymptote is at 0. So I'm going to go draw my graph right here. You're going to notice that negative 1 and 1. I've got my vertical asymptotes. Horizontal asymptote right here. So notice every single interval was decreasing. So since every single interval is decreasing, that means it's always going down. So notice it would have to be going down. That's the shape that looks like. This one is going down, so that's that x cubed shape in the middle going down. And then this one is also going down. And so that's what your graph will look like on number 8. Okay, now on number 9, we're going to go ahead and graph this other problem right here. So on number 9, it says I got y equals x cubed minus 3x squared plus 3. Follow the graphing rules for number 8. You're going to notice that there is no denominator, so there is no restriction on our domain or range. There's no vertical or horizontal asymptotes, so your domain and your range are going to be going from negative infinity to infinity. So basically all I have to do is do the first derivative test. So I'm going to take this equation right here, y equals x cubed minus 3x squared plus 3. Find this derivative. So derivative of x cubed is going to be 3x squared. Derivative of negative 3x squared is going to be negative 6x. And the derivative of plus 3 is going to be 0. I go and factor out of 3x. Out of this equation, when I do that, I get 3x times x minus 2, set that equal to 0. And so now to find your critical numbers, setting each one of those equal to 0. I got 3x equals 0, so x equals 0. I've got x minus 2 equals 0, so solve that, I get x equals 2. So now I got to go ahead and set up my intervals. I'm going to go from negative infinity to 0, 0 to 2, and 2 to infinity. Choose a number between negative infinity and 0, I get negative 1. I'm going to substitute that back into this equation right here. So notice when I put a negative 1 into this part right here, that's going to be negative. I put negative 1 into this part right here is negative, and negative times a negative is going to be positive. Go to the next one. Choose a number between 0 and 2. Choose the number 1. When I substitute in 1 right here, I get a positive. When I substitute 1 into this equation, I'm going to get negative. A positive times a negative is negative. Now the next one I choose is 3. Substituting this derivative right here, I've got 3 times 3 is going to be 9, so that's positive. 3 minus 2 is going to be positive. Positive times a positive is positive. So those are my intervals right there. On this problem right here, I have to go ahead and find those values that correlate to the x values. I have to find the y values that correlate to it. So notice this one right here. So this is x equals 0. So I'm going to go ahead and go to my original equation. My original equation is right up here, and I'm going to substitute in 0 in that original equation to find out what the y value is that goes with it. So when I substitute that in, I'm going to get 0 cubed minus 3 times 0 squared plus 3. So that's 0 plus 3, which is just equal to 3. So that y value that correlates to that is going to be equal to 3. So there's a point 0 and 3. I'm going to take this x value right here, 2. I'm going to go ahead and substitute it back into the original equation to find its location. So I'm substituting in 2 in this original equation right here. So I've got 2 cubed minus 3 times 2 squared plus 3. So 2 cubed is going to be 8 minus 2 squared is 4. 4 times 3 is 12. So 8 minus 12 plus 3. So 8 minus 12 is going to be negative 4. And negative 4 plus 3 is going to be equal to negative 1. So that y value that correlates to that x value is going to be negative 1. So the reason why I had to find those is because that's how I'm going to graph it. So notice I go to 0 and 3, put my dot there. I go to 2, negative 1, put my dot there. And I go looking back at my intervals. My interval says from negative infinity to 0, that is increasing, so it's going to be going up. And then from 0 to 2, that is decreasing, so that is going to be going down. And then from 2 to infinity, that is going to be going up. And so that's what your graph is going to look like.